Good day, viewers. You're welcome to our YouTube channel, Master Davic and Victor Adewale Adeleke. Okay, without wasting much time, let's quickly dive into the deal of the day. Okay, today we have proof of Pythagoreans or trigonometric what identities. This is the second video I'm creating, and this one specifically is dedicated to calculus students that are in tertiary institutions that are preparing to delve into the trigonometric aspect of calculus. It is very important that you understand this concept of trigonometry, else you might have problems simplifying trigonometrical part of calculus. You might just be cramming calculus, and that is not what calculus is all about. Understanding it and knowing how to bring out the solutions you are looking for matters a lot. So you don't need to cram their concepts in calculus that the derivative of tan is going to be sec square. No, you don't need to cram all of that. Just understand the process or the procedure of your trigonometric identities, and everything will just be sticked to your mind. If you forget anything, you can prove them out yourself. Okay, now let's see quickly what can we do here. We have a right angle triangle characterized by an angle 90, and I've explained this in my previous video, proof of trigonometric identities 1. Go and check that video quickly. I explained how that this place became opposite here, adjacent, and here hypotenuse. Okay, one concept I gave was that since the angle 90 is facing this direction, it is also what it is, because it's facing this direction, that is the angle 90. Then this x you are seeing here, which is the angle, the adjacent side and the hypotenuse side are always having an angle theta between them. Yes, always having an angle theta. So whenever you are looking for the adjacent and the hypotenuse, the angle theta must be in between them, or the angle, any angle x, angle theta, whatever, or angle y, whatever you are making an angle, must be in between what? Must be in between the hypotenuse and the adjacent. While this place left is the what? Is the opposite. So I just labeled them A, B, C. There's nothing to panic about. Now remember Pythagorean said a square plus b square equals what? C squared. Okay, this is not really the deal of the day though, because I've already explained how this brought about the trigonometrical or the Pythagoreans identities. I gave 3 different Pythagoreans identities. So today I just want to simplify some basic stuff that we need to know. Once you've noted that, now remember I also said something of this nature. I said so ka twa. Yeah, this is what I said. This is sine theta equals, so these are trigonometrical functions and tan. So we have sine theta, cos theta, and tan theta. So sine theta equals what? Opposite over hypotenuse. So we can just say that what? Sine theta equals, what's the opposite there? Opposite is A. I'm going to be using the labels this time because we don't really need to waste our time. So opposite is A divided by hypotenuse. Hypotenuse is what? Is C. So what do we have? We have cos theta. Cos theta equals adjacent over hypotenuse. What's the adjacent? The adjacent is B over hypotenuse, which is what? C. Then we have what? Tan theta. Tan theta equals what? We have opposites over adjacent. What is the opposite? That's A. All divided by what? All divided by adjacent, which is what? B. Now all these 3 trig functions, they have their respective inverses. We have cotangent, we have cosecant, and we have secant. But now we need to know, the problem many persons have is they don't know who is the inverse of who. So now it's very simple. It is very simple. Now remember this, just remember this concept that just remember this. Look at the spelling for cosecant. Cosecant. This is cosecant. Then we have cotangent. 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 And we have secant. 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 Now what you need to know is that just watch their third letters. So don't be confused. Just watch their third letters. So whenever you remember any of those inverses like cosecant, cotangent, secant, just remember their third letters. S. This one here for cosecant, the third letter is what? Is S. So automatically it means sine is going to be the inverse. So you can say cosecant is equals to 1 over what? Over sine. So just say cosecant x. Oh, we are using hex. Sorry about this. We're using hex. Don't forget that's what we made our angle. So we're using x. So cosecant x is going to be equals to what? 1 over what? Sine x. And 1 over sine x will be equals to what? Since sine x is equals to 1 over a over c, 1 all over sine x is going to be the inverse of what? of A over C, which is C over what? A. Yes, you can check that out. I think I should show that. Now we have 1 divided by what? Sine S. What is sine S? Sine S means A over C. Now what does that mean? It means 1 divided by A over C. Remember the basic rule of what? Of division. When you are converting into multiplication, you turn it to times. Then the right hand side, the fraction at the right hand side is what is inverted. So we have C over A. C over A times 1, we have C over A. So that is how it became C over what? Over A. So you can see that here. So cosecant x is equals to the inverse of what? Of sine x, which is equals to what? C over A. So what about cotangent x? Yes, cotangent. Look at the third letter is what? Is tan. So it's going to be what? 1 over what? Tan x. I hope this is clear enough. So 1 over tan x. So you already know what that would be. It will be what? The inverse of what? A over B, which is B over A. Then the last one, secant x. Secant x, what is the third letter? A, C. So we have cos. So 1 over what? Over cos x. And 1 over cos x will bring out B over C. But since we have 1 over cos x is B over C, but 1 over cos x will be the inverse. So we have C over what? Over B. So these just are a very perfect algorithm that you can use to always remember that. So secant, the S, the T, and the C, those are their inverses. Now, mind you, they are also like that. They are also vice versa. You can also say that sine x is equals to cosecant 1 over cosecant x. Because look at it, if you check it properly, if we say cosec x is equals to 1 over sine x, you can do a basic mathematics here. You can do your cross multiplying, and you have finally, and you can make subject formula of sine x, that sine x will now be equals to 1 over what? Over cosec x. So you say that now. So from here you can still get it. So sine x is the same thing as the inverse of cosec x. So in case you see that cosec x is equals to 1 over sine x, and see some other person saying sine x is equals to 1 over, they are still the same. They are what? They are vice versa. You can just understand it like that. So that is it. So once you've noted that, let's see what we can do quickly from this table. We've discovered now for the trig function, we discovered that sine x will be equals to what? Will be equals to A over what? A over C. Yes. And we have discovered also that tan S, okay, let me just, since my hand took that first, tan x will be equals to what? A over B. And what? And cotangent x, no way, these are all for the trig functions, not in the inverse. So we have that cos what? X will be equals to what? Will be equals to B over C. Now once you've gotten that, now let's take their inverse. The inverse of sine now is going to be what? Cosecant. Cosec x will therefore be equals to what? Will be equals to what? C over A. And for this one, tangent x, which is cotangent x will be equals to what? Will be equals to B over A. And for the last, that is secant x will be equals to what? C over B. Okay, without wasting much time, let's see, there are other things that can also be divided. Because when you are going deep into calculus, you'll be seeing some stuff like cotangent x divided by sec x. What will it give you? You get stuff like that. So let's quickly see what we can do about all of that. Okay, now many of you have heard that sine divided by cos gives you tan. You have heard it severally from several persons. I will get confused. How did sine divided by cos give you tan? From this expression here, you can do that. So if we want to check that, I want to try that. We can say sine x divided by what? Cos x will be equals to what? Now what is sine x? Sine x is A over C divided by what? Cos x. That is B over what? Over C. And if you are rewriting that, this could be rewritten to become A over C divided by what? B over C. And like what I just explained, the basic rule of division, when you convert it to multiplication, what happens? The fraction at the right hand side is inverted. So we have C over B. So what happens here? C eliminate out C, and we have A over what? B. And if you check who is A over B, A over B is actually what? Tangent x. So therefore sine x all divided by cos x must be equals to what? Tangent x. So it was not magic. This was how it came about. A divided by b. You can see the way everything was simplified to becoming what? Tan x. Okay, now let's see. What about okay, this was sine divided by cos, which is tangent. Now this thing also applies. It is still the same. Okay, let me just put an arrow. Now what is the inverse of sine? What is the inverse of sine x? Yes, the inverse of sine x is what? Let's see. Inverse of sine x is cosec. So we can say that, we can also say that cosec x divided by what? What is the inverse of cos? That is sec x must also give you what? The inverse of tan, which is what? Cotangent x. I hope this enters my screen. Cotangent x. So this is cotangent x. Yes. So cosec x divided by sec x is the same as cotangent x. The same. What happened here? That's what was transferred to this place. Okay. Now let's see. Let's see also. Okay. What about let's see. What about if we have? Okay. Since we already know that, so we found that automatically that what that cotangent x is equal to 1 over tan x and secant s is equal to 1 over cosec s. So automatically it means that this cotangent s that we got here, which is this cotangent s, yes, is same thing. So we can also put 1. So this can also be equals to what? Okay, sorry. I mean this one here can also be equals to 1 over what? Tan x. That is by the way. Okay, now let's see what we can quickly do. Okay, what about if we are saying cosec x divided by what? By cot x. What will this give you? We don't know. I don't know. But let's see. What will cosec x divided by cotangent x give you? Now, what is cosec x? I'm trying to minimize my space. What is cosec x? Let's see. Cosec x is equal to c over a. C over a. Okay, now let's quickly do the little arithmetic here. C over a divided by what about cotangent x? Cotangent x, yes, that's b over what? Over a. So when we do this arithmetic here, we can say c over a times, it becomes times. So this one is inverted. We have b over, we have a, sorry, over b. So what happened here? A cancels out a, and we have c divided by b. Who is c divided by b? Okay, let's see who is going to be c divided by b. C divided by b was what? Was secant x. So automatically, which means that this will be equals to what? This is also another way to write what? Your secant x. Cosec x divided by cotangent x will give you what? Your secant x. Yes, very adequate. Now, once you have done that, this can also be rewritten to becoming, what is cosec x? Cosec s. Okay, now let's see cosec s. But okay, this can also be rewritten to become, okay, this, another way to see this also from the trig functions, not from the inverse function. Now another way to see this is, what is cosec s? Now we know that cosec s, the inverse of cosec s is what? Is sine x. So we can rewrite that to be sine x divided by, what is cotangent? Cotangent is what? Is tan x. Tan x. Now you can see that now. So automatically, yes, exactly. So you can see with me that sine x divided by tan x is going to be equals to what? What is secant now? Secant is what? Cos. So we have cos x. So don't get confused. So cosec x, what is cosec x? Look at the cosec x here. That was the sine. So we dropped it there. We are taking from this table now. Sine. Then cotangent, we took tan was equals to sec x. We discovered that. So automatically it means the same thing applies to the trig function. Not even whatsoever applies to the inverse function also applies to the trig function. Whatever division you carry out in the inverse function can also be carried out in the trig function, and the answer will still be the same. Nothing spoils. Yes, everything will still be equal to each other. So we have sine x divided by tan x is going to what? Provide what? Cos x. Okay, let's see. We've already used this already. Let's see what we can do again. Let's see what we can do quickly. There are very many things you can do from this little table that I gave already. There are very beautiful things you can do from this table. Just understand what you are doing, and you'll find out that everything still comes out to be the same. Okay, let's see. What about tan divided by sec? Yes, What about tangent x divided by what? By sec x. Let's see what it will give us. Tangent x divided by what? By sec x. Now we know that tangent x is what? A over b divided by what is sec x? C over b. So turning this to a multiplication, we have divided by, we have b over c. B eliminates out b, and we have a over what? Over c. And who is a over c? That will be what? Sine x. So another way to write that, to write sine x, is what? Tan x divided by sec x. All these are just the way you can play with this stuff yourself. So from there we can get that what, we can get the inverse also still will still work. So check what is tan, this is it. We have therefore that cotangent x all divided by what is sec, that was cosec x will be equals to what, must be equals to what, sine. What was sine? That was cosec x. So that is it. So the same thing applies. Nothing spoiled, nothing is missing, and you can also do this for many more that you can do. Just find functions that have the same base and divide them and check what the result is going to be, and your answer falls out as a pack of cards. Nothing is confusing here. Just understand your system of operation. And mind you, this is not all there is. Go back and make sure you make reference to my video, proof of trigonometric identities or Pythagorean identities 1. Yes, make sure you check on that video. Yes, and it will really complement what I did here. Then once you've watched those videos, you can jump into your calculus trig identities, your trig identities calculus, and I bet you are going to understand every single bit of what was done there. If you are yet to subscribe to my YouTube channel, do want to subscribe, like, and share. Stay tuned.